Welcome to another Robolink tutorial. So today we're going to be programming the motion capture robot. So if you haven't watched our tutorial videos on how to use the sensors and motors, I recommend you go back and watch them. So the motion capture robot is pretty simple. The closer you get to the middle sensor, at one point it will trigger the robot to close its hands. So you basically don't want to get caught by it. So the first thing we're going to add to our code is going to be our smartinventor.h library. Um, Again, we use that for motor sensors, all that good stuff. We're also going to have two global variables. The first one is going to be the location of our left sensor, of our center sensor, so the one that we're going to be trying to get as close to as possible. And the next one is gonna be an offset for that sensor for when we calibrate it. Pretty easy global variables. Next, we're gonna have our void setup. So in void setup, since we're gonna be using our LEDs as indicators for this one, we're gonna initialize them all to be outputs, and we're also gonna start them being off. Since we don't This should be common practice to do this unless you want to have one or two on to indicate something. I usually turn them off and set up as well. We also gonna tell our motors that we're gonna be using them in void setup, so we're gonna do a motor use there, and then we're gonna set a delay here of 500 milliseconds, just so it waits a little before going into the void loop. Right. So for void loop, now we're gonna have one thing happen first, and that's, unlike other videos, we're gonna do the sensor calibration in the void loop. And the reason why we're doing this is this is gonna allow us to be able to get closer to the middle sensor without it triggering every time we just simply get in front of it. So if every time it's calibrating the sensor to see what the normal is we're gonna be able to play our game a little bit better. So we're gonna set our default. There you go. We're gonna create a variable called default, center default, and we're gonna call the smart inventor that sensor calibration. We're gonna tell it that we're using the middle sensor A1, and we're gonna subtract the offset from it. So this is gonna allow us to get closer to the middle sensor, and as we're getting closer, it's not just triggering, it's gonna keep checking, and at one point it's gonna cause it to go into it to make the robot work. Sorry about it's kind of a long sentence there, so kind of hard to see. The next thing we're going to do is we're going to have our sensor value, and we're going to call analog read, and we're going to store that value. And we're going to use that for checking whether we're close enough to the sensor. Now each time we get to this point, we're going to turn off the LEDs again. So each loop time the LEDs are going to get turned off, and then we're going to do something clever. So we don't want all the lights to be on at one time, but we want them to indicate whether we're getting closer to the sensor. So the way we're going to do that is we're going to create this variable called sensor, and it's gonna be like an offset for the lights. And what it's gonna do is we're gonna read the sensor at this point, and we're gonna divide it by 200. And what this is gonna give us is gonna give us a fairly small number, like between 1, 2, and so on. But the closer we are, the further we are from the sensor, the larger this number is. And the reason why we're doing that is that we're gonna subtract that amount from two other variables that we're gonna create. Speed meter. So this stands for the LED 14, and this one stands for LED 15. So those are the middle sensors. If we're really far away from the board, we're going to subtract a large number from it, and it's going to cause this to be, maybe for example, if we're far enough, it's going to cause this one to be 18. I mean, no, this one would be 11 because we're subtracting, and this one would be 18. And then the closer we get, this one becomes um, 12, 13 until it gets to 14, and this one goes down 17, 16 until it becomes 15. And then at that point is when basically our robot would react and try to close their hands or his hands. Um, and then we're gonna write whatever that number becomes. We're gonna write to the LEDs.